Hi, and welcome to Väike Saal, or the small hall. So we will have 6 talks here today, 3 before lunch, 3 after lunch, and for each there will be about 25 minutes for the talk itself, then 15 minutes for the Q&A roughly. So because we are in a virtual conference, we will not need much time for a switchover, no need to plug in or unplug your laptops and all that. So it's a bit easier. Unfortunately, as we've been having some difficulties with the network over here, so it's kind of the same every year, but this year it affects us more than usual because everything we do here goes live to you guys over there. But thanks for bearing with us, and we hope to give you some great content nevertheless. So the first presenter in Väike Saal today is Hua, who has been living in Tallinn for quite a while now, works at Playtech or VideoBet Estonia, is the development QA team lead there. And he's going to be talking about artificial intelligence in test automation. Definitely a very interesting and exciting subject to start the day off with. So the floor is yours.
Thank you, Christian, and good morning, everyone. And as you can see, that my first slide, and today I'm going to share my experiences how to adopt artificial intelligence into a test automation practice. First of all, please allow me to introduce my background. And I'm a certificate Scrum Master and testers with 15 working experiences. Currently, I'm working as team lead and Scrum Master for VideoBet, Playtech company in Tallinn, Estonia. I'm the main architect of VideoBet continuous integration automation test system. I'm also leading all the agile testers at the Tallinn side. I really like to share my experiences with others. I have guided and trained more than 40 new employees and interns. I'm also the chosen mentors of Estonia Valley IT program since 2017. And here, usually I got some interesting questions already. And, how many years have I worked in Playtech? The answer is, well, it's around 15 years. People said, wow, 15 years. But how long time you have lived in Tallinn, like Christian just mentioned? My answer is that a bit more than 15 years. And people say, wow, more than 15 years in Estonia, how comes? And it's a small country, that what bring you here? And here, actually, I have very interesting questions that how I came to Estonia. Back in 2004, when I studied my bachelor degrees in Beijing, I decided to continue my study abroad, but I haven't decided where I should go. So I participated the international education exhibition in Beijing in 2005. Basically, all universities around the world sent their representatives to introduce their international program. So I went there as well. And I found one very interesting booth, very nice decoration, very nice, huge background, were very nice landscapes. Later I found out actually that is the old town of Tallinn, just like the picture right now I showed to you. And there is very nice ladies standing over there and try to introduce their program, but nobody went to talk with her. I was thinking that, guys, you are so rude and impolite. Come on, just talk with her, you know. So I just went to talk with her to ask the information about the international program. The girl was so excited. Probably I was the first one she talked with that day. So she introduced me everything in detail about Italian Technical University's the program. And she asked, do you know about Skype? I said, of course I know Skype. He said, Skype is from Italian Technical University. It was born there. I said, wow, it's so cool. And they said, look how nice our campus it is, you know, a lot of forests and so on and so on. I said, wow, so nice. Advanced technology, very nice landscape. Why not? I have to go to check it out. So after I graduated my bachelor degree, and I came to Estonia to continue my master study. I came at 2006 September. Everything just like she described. Very nice weather, beautiful landscape. But old town is fabulous, as she told me. Campus is nice. People are friendly. Everything's very nice. Until I found out in Estonia, probably she forgot to tell me that Estonia winter on, a little bit dark and a little bit cold. But I'm a very positive person. You know, when I face a challenge, I want to find the solutions to resolve it. So I decided to search on internet how to survive Estonia winter. I found a lot of tips. I think I managed pretty well. That's why I survived the last 15 years. So people said that, what do you work in Playtech? I understood that the Playtech is the gaming company. Is that you playing games? I said, no, pretty much. That playing games is a part of our work, as you can see. And the video bet is the retail group of Playtech, and we mainly focus on the landscape terminals, so that those are the betting shops. So people said, "Oh wow, that your job probably looks like this." That sitting there and playing games and get paid. That my answer is that, well, yes and no, and part of our it is to verify for the especially from testing perspective. Let's have a look. One of our interesting test cases, right? That to playing games to verify those pop-ups. It's very simple. You have the ready terminal cabinets. You launch the game. It's a touch screen. You click on game. You saw there's soft keyboard and service window pop up. And our job for this task is just to verify the soft keyboard pop up or not. Now you may ask a question that why we have developed this keyboard for our betting systems. As you can see, the game is launched, and when we want to log in the loyalty players, and you have to input the player username or password. So at this moment, and you will use this keyboard on the touch screens. So then people said, "Oh, you still like playing games, right? You're playing games. You pretend you're like a user. You log in. You continue to play. You gotta pay." Yeah, it is like this. It is very easy task. But I forgot to tell you that we have a few hundreds of games, right? And we have different theme as well. The theme means different color and different background of the game. And we also have different type of the cabinets. If the different type of cabinets, it means different resolutions. As you can see, here are a few examples. Some of them are using touchscreen, 4 screens. Some of them are 2 screens with hardware buttons. They are all meant about different solutions. And as everyone knows, we might have quite many snapshots built. For us, average is 1 or 2 snapshots per day, which means multiply 5, which means 5 to 10 snapshots. So just to verify the overlay pop-up, the keyboard open or close correctly, the possible test cases equals number of games multiply number of cabinets multiply number of things and multiply snapshots built. If I test this manually, you can imagine I will most probably end up one of the exhausted engineers, like one of them over there. But remember, I'm quite a positive person. If I face a challenge, I start thinking about the solutions. I don't want to do this manually. I want to do it with automation. So I dig into automation solutions, and I thought if I implement automation solutions, it should work like this. Completely automated, one click, and everything move. I should hold a cup of coffee and watch how nice the automation work. The traditional automation programming works like this. We'll define the data and the rules, and it generates the results. At this moment, our data is the screenshots of the games, and the rules is to verify that the pop-up is on the picture or not. So with this traditional automation programming, no matter you use Selenium or SQL, probably you have used a lot, it will work. And you have to define the rules by yourself and to verify the picture on each of them. It sounds quite easy, but if we see how diversity could be amongst all the images, let's take an example of this rock, paper, scissors images. If we take a look at them, you might find how different people can demonstrate the rock and scissors and papers. People sometimes do like this for the scissors. People sometimes do like this. People sometimes do like this. Doesn't mention about how to say, like different hands gestures and so each of the images we have to program. So the possible automation code will run like this. Besides this much work, we still have to face some common issues in our traditional programming. Legacy code, flaking test, and human errors. Everybody knows about the legacy code. It's those code we have inherited from somewhere that we have taken a lot of time to understand it. Sometimes we don't know why we even use it. FLAKY test is also very common issues during the automation programming. Flaking test, mostly it is this type of the test that pass or failed occasionally, randomly, without code change. It takes us a lot of time to understand them and maintain them. Those flaking tests usually caused by the network interrupted and slowness of the database loading. For us, as you can see, if we use this way to program, to do run the automation, I might end up again like those kind of exhausted engineers. And I don't want to do that. For us, it's tough work, overloaded. From management perspective, that is a huge amount of cost. And the cost term of so-called automation, which should help us to make our life easier. As I mentioned at the beginning, I have, in my 15 years in Playtech, I have trained a lot of employees and interns. I have lots of experiences how to train new employees. It makes me think, if I have lots of experience to train people, what about I can train the artificial intelligence, the neural network? So I start to look into the solution. First of all, what is machine learning and what is the artificial intelligent neural network? In this picture, 8 pictures, which ones are shoes? You might tell me that the red ones are shoes. That's correct. But because of the color and you recognize they are shoes? Apparently not. And because of the shape? Not so. Actually, in terms of the shape, the high heels and the sneakers are quite different from shape perspective. But why we recognize they are shoes? Not clothes, not bags. Because our brain have been trained so many times with the shoes. We know what is the image of the shoes. We have seen them many, many times in our life. That is the new way of thinking. We give data, the pictures, and we give answers. And we can let the machines to figure out the rules instead of us to define the logic, how to judge. Then we can use the rules which has been figured out by the machine applies to the testing. This is logic behind. And nowadays, the artificial intelligence neural network is really good at image recognition to recognize what is on the picture, to detect the object from the image, and video detection and analysis. You can right away say that on these videos, what is the object and what is the probabilities of it. So in our case, come back to our user case, that we want to verify the soft keyboards on our game images. So we applied the ImageAI libraries to achieve our goals. So what we did? Firstly, a few words about the ImageAI. It's the Python library. It's free and open source. So how we set up ImageAI, that we need, as mentioned, is a Python library. So we will install the Python, and here we install Python 3.6. I would like to emphasize that if you also want to practice with ImageAI, you need to pay attention that the ImageAI's version with the Python libraries, my Python versions. And for IDE, we use pie chart. And just to check out from the repositories as well, as usual from the GitHub. We were to mention that the latest version is Red 2.4, and we were using 2.02. The main two parts of the practice this artificial intelligence test and automation is testing and prediction. Let's go through one by one. Firstly, let's have a look how we train and prediction, and how we train the model. So to train the model from ImageAI is very simple. Few of lines. Let's go through one by one. First line is to import the model training. The second one is to select the calculation algorithm. And here we selected ResNet. You already know about it. This is powered by Microsoft. And it's worth to mention that actually the ImageAI support 4 different calculation algorithms. The third line, keyboard, to define the data directly, as we are trying to verify the keyboard is open or not, so we name it the keyboard. And the fourth line is to set up the configuration of the training models. We'll go into a little bit more detail in next page. There are many parameters to set the models, the training models, and the most important are those 3: number of objects, number of experiments, and the batch size. First, number of objects. Here, you need to define that how many different categories in your training. In our case, we need to verify the number, the keyboard is open or closed, so it's 2. Second, number of experiments. Basically here, if you just define the number of experiments, afterwards that you will know how many models will be generated. Batch size, once how many pictures it will training. Here is the categories, how it looks like in this in our IDE. As you can see, we have 2 categories: keyboard open and keyboard close. And in each of the categories, we have set that 200. In total, we have 280 pictures, and each of the categories it was 140. And as you can see, there is like a testing folders and training folders. We're talking about the 280 were located in the training folders. Testing here is not the predicting what we are how to say really to testing. Here is we're using test image to verify that the pictures how close is with the target images. In testings, we have set up 40 pictures in total. So here, as you can see, and this example of that keyboard open picture that we have collected, it's worth to mention that those images have also been collected automatically by another utilities have developed by us internally, so we don't have to go through take those images manually. And this is another example of the keyboard close. And after we take the screenshot and we have labeled them, we say that keyboards and the name of the game, gem hit, and name close. So we know that this keyboard is supposed to have no keyboard. This picture is supposed to have no keyboards. Hardware, we don't use any specifics in our case, and we just use a normal laptop to train it. It's worth to mention that during our training, we mostly use CPU for them. Here is a very interesting one that when the training started, that we can see there are multiple lines. Here, that the first one is 14 loops, because that and the first one is training. Last 2 is the testing, because we train and to take this model to verify it with those ones. And why it's like this? Because that we have to generate 200s, so 20 loops. So 20 multiplied 14. That's why here we have 14 rows, and we have 40 pictures and 2 lines here. So it will be 2, because 2 multiplied 20. I quickly explain you that here that what is meant. And ETA is time estimation, how long time each of the training paths will take. And loose and accurate function, actually, they are main functionalities of the Keras API. Loose is calculated how differences between the testing images and the trained ones. And this one, and our job is to train this artificial intelligent neural network to reduce this loose value and accuracy and increased accuracy value. So that, as you can see, at the end of the training models, and the accuracy value should increasing. This after training, the model has been saved, right? From first one to 200. If you remember that we set this number of experiments to 200, so it will be totally 200 models will be generated. Generally speaking, that the accuracy rate is increasing, but not always. And when during the next step, you will choose the most accurate ones, which is the highest accuracy rate, usually is 1. About the training speed, and as I mentioned that we mostly use that we only use CPU for our training. The main reason is because that the TensorFlow versions of it. If we update the whole ImageAI to newer version, so it supports TensorFlow 2.1, and we can use GPUs for the training, and you also can practice with Google Chrome TPUs for the training to speed up. It's worth to mention that the Google Chrome is only support TensorFlow Lite model, and here, as I said, that we use actually only TensorFlow. So we have to convert. If we want to adopt this TPU, we have to convert CPU, the TensorFlow model to TensorFlow Lite model. So here's the prediction. As I said, that we will select the best model of it, the highest accuracy rate. Second, define the target folders for testing images. Third, to define the failure probability rate, right? Then you will tell that after below this rate, then this test gets failed. Then you can start to run the tests, and automation reports will be generated automatically afterwards. So here is the example that what the test has been generated. So we use another pictures with testing for it, and the probability was generated with the model we selected. Then the probability is 96%, which is correct. And keyboard close, and the probability of being close is 98%, which is also correct. And here is the example of the report. It's perfect with me, very good. And here, that you can see that the test name of it and the date of it and the path, probability for the pictures, and you can see the picture is closed or we judge it's closed or open. If it's closed, if it's below on the defined failure rate, we will say that fail due to insufficient probability percentage. And then we moved this one to the failure report. This one has been developed by ourselves. The roadmap. So what we will do then next? So that we want to gather more test images to expand the number of the categories. So as I mentioned, we have only 2 categories at this moment: keyboard open and keyboard close. And if we want to pick up any specific ones, for example, the keyboard is open half, and we have to train this specific category as well. So second, to update all dependencies to the latest version. As I said, that we are using the older version of it, and if update the newer version, then we can speed up the training process, and we can explore more new features with ImageAI, such as the object detective and the video. Right now, we are using only image recognition. So summaries that what you can learn from this one for takeaways. First of all, as you can see, that the most important is to choose the suitable test scenarios, test the automation. And every step is not like jump, or how to say, like just jump in my mind, and it's step by step. And we've tried automation, and it's not suitable for the scenarios. And that's why we adopt these methodologies. Second, find the suitable dataset for your AI model training. There are many existing AI model datasets like Kagos, and you can use them already for the training. But if from your work some specific scenarios, it will be good to collect your datasets by yourself. The third, model training plans should be included at least 2 different image categories. This one I already mentioned. And fourth, optimize the training plans for testing results to improve the AI model accuracies. Just like I said, that we can collect in the map, we want to collect the most snapshots, more different data sets to cover all different more scenarios. Okay, that's about it. Thank you.
All right, thank you, Hua. Some questions now from the audience, and again, just I forgot to remind at the very beginning that please put your questions in the Q&A section in Workshop, so I will get them from there. But I have some questions of my own, even if there are none there yet. So, yes, so first, let's start at the very beginning. For example, if someone is just now starting up to build their test automation, should they already be looking at AI or try it the hard way first?
Very good question. That, as I mentioned, that to choose the best approach to adopt is very important, and to adopt the artificial intelligence is not the goal. To resolve the challenges, the issue you have at work, that is the goal. So for many scenarios, automation is good to do, like Selenium automation is very good. For example, I just want to click the button like 10,000 times. It will be very good to just use any existing automation frameworks. And here, that if we want to more simulate this human ways to read, and it will be good to use at this point that the image recognition is very good to adopt. It's good scenarios. So to answer your question, if you are new to use test automation, that I suggest that you can first judge by your scenarios what should you do, and now choose the best ones for you.
Mm-hmm. So essentially, AI is not a silver bullet, but it's just one of the tools in the tester's toolbox.
Exactly, it's one of the tools in your toolkit, and we are, how to say that, we are end users of the test automation solutions. So it's very important to understand what is the current power of artificial intelligence neural network. It developed very fast. For example, before, and it's only can you can take example of AlphaGo. Before, and it always lose to the people, but right now is you can beat all this the best human players. So the artificial intelligence developed very fast. the most important is we know what you do, what you can do. So to use it to cover your work needs. So you don't have to push it, you don't have to develop it, just use it wisely and with the existing features.
Thanks for that. We have some questions from the audience as well now. So how much time are you spending on maintaining the automated tests?
I guess he or she meant about this AI test.
Most likely.
Okay. Yeah. So if we are talking about these particular solutions, and the main goal is to save our maintenance time. So for example, before I have hundreds of games, have different themes, different cabinets, different screenshots. Everything new comes, I have to change my test automation screenshot the elements. If you have experiences with automation, right? So, and this AI solutions resolve this problem pretty well because it has been it's like a people, you have learned that already. So if the new images come, you don't have to change the image elements anymore, and this AI will figure out by itself. So from this perspective, it helps us a lot. And the new games, new image comes, and we don't have to change and maintain our test automation. So in this perspective, and after you develop and train it, and for us, the maintenance time is nearly zero.
All right. That sounds really good. So we actually don't have much time left in this Q&A session, but we have one more question from the audience. It looks like a long one when I'm reading it, but I'll try to fit it in. So the question talks about that the example implies the evaluation of one test scenario, which is a picture. How does the whole picture cycle scheme of test automation look like if we integrate image recognition to end-to-end testing?
I have to say that because of our copyright, and I'm not allowed to show that all the picture sets in my demonstration, and because the games are from third parties. So actually, that talking about the training, there are 280 pictures, and actually there are if we're talking about the games, there are 140 games because they are keyboard open and keyboard closed. So there are 140 totally different games we have went through them. So, and I don't have time to show you everything. If next time I still have a chance, and next year I probably can run the workshop and to show you guys step by step and how to set it up and how to train and how to talk with it. And here today I mostly want to bring this message that don't be afraid to embrace the new technologies, and it do help us to resolve some of the problems that we have been facing the test traditional test automations.
All right, thank you. Thank you very much. Here would be the place for the applause in a normal conference and me giving you a gift bag. But well, times are as they are, so we will find another way to get us our gift, which this year is a Nordic Testing Days themed face mask.
Yeah, but I hope that we will meet soon and next conferences, and I hope that we can talk for sure.
And for sure, a workshop next time around would be excellent on this topic. So don't forget.
I hope that the audience like it. Yes.
Yeah. So don't forget to submit it when we announce the next call for papers.
Okay.
All right.
Great.
Thank you.
Thank you.
So